So today I'll take the topic on Lamy's theorem. Lamy's theorem. So Lamy's theorem basically states that if three forces, okay, here we are considering three forces acting at a point, okay, if there are three forces, we are considering three forces which are acting at a point. If three forces acting at a point are in equilibrium, okay, then what can we say? If there are three forces acting at a point which are in equilibrium, so here I have drawn a body, and at a point O there are three forces P, Q are acting at this point O. Okay. Now let's complete this theorem. If three forces acting at a point are in equilibrium, then each force, okay, each force is directly proportional to this each force. If we take P, this P, that those individual forces, each force is directly proportional to sine of angle between the other two forces, So this P force, okay, we're taking one force at a time. P force is directly proportional to, let's mark the angles here. Let's mark the angles. This is alpha, okay. So alpha is the angle, okay. Alpha is the angle opposite to P and between the other two forces. Okay. Now let's mark the other angles. This is gamma. Gamma is the angle opposite to R. And this is beta. So each force is directly proportional to sine of angle. Okay. Sine of angle between the other two forces. Identify the angle opposite to P, or let's say corresponding to P. Which angle should we consider? Corresponding to the force P, which angle should we consider? Opposite to P and between the other two forces R and Q, the angle is alpha, right? So we can apply this theorem to write it in another form using Lamy's theorem. We can write P by sine alpha, okay? P by sine of alpha. Alpha is the angle opposite to P and the other two forces. P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. So this equation we'll use to find various problems. Okay, this is the equation using Lamy's theorem. Here in this question, a block P is equal to 5 kg and a block Q of mass m kg are suspended through a cord as shown in the figure. So we have two blocks P and Q. And this entire system is in equilibrium. In this question, we have to find the mass of the block Q. So here, the block Q, we have to find the mass m. Okay, mass m we have to find. So the solution of this question is, since this entire system is in equilibrium, we can consider the point B. Okay, first consider the point B. This is point B. Okay, now we can see that in this figure there are three forces acting at the point B. Considering the point B, okay, there are three forces TAB. Okay, TAB is the tension acting in the chord AB. Okay, TAB is the tension acting in the chord AB. Now TBC is the tension acting in the chord BC. And we have a weight acting downwards. We have a block P suspended downwards. So it has a weight of P is equal to 5 is the mass given. 5 into 9.81. We write it in terms of weight. 5 into 9.5 into 9.81 Newton. Okay. So now we have three forces acting at the point B. We can find the angle between these forces also. So in this figure, 30 degrees is given. Okay, so we can find the remaining angles here. This angle theta will be equal to tan inverse. The slope of the chord AB is given. So tan inverse, we can find this angle. Okay, opposite side by adjacent side. Tan inverse 4 by 3. Tan inverse 4 by 3. Opposite side by adjacent side. That is equal to 53.13 degree. So this angle will be equal to 53.13 degree. Now we can find this angle. Okay, 180 minus 53.13 degree plus 30 degree, and that is equal to 96.87 degree. So at the point B, we have found all the unknown angles. Okay, now this is already we know 90 degree, 90 degree. So we can find this entire angle. The angle between TAB and TBC we've already found out. Okay, 96.87 degree. 96.87 degree. Now we can find this angle 53.13 plus this 90 degree. We will get it as 143.13 degree. Now this remaining angle also we can find by adding 30 degree plus 90 degree, that is 120 degree. So now consider the point B. We have three forces acting at point B which are in equilibrium, and we know the angle between the forces. So what can we apply here? We can apply Lamy's theorem. Apply Lamy's theorem. So Lamy's theorem, we can say here at this point B, we can say TAB by sine of, considering TAB and the angle opposite to TAB between the other two forces. The angle between the other two forces TBC and P is 120 degree. Okay, this 120 degree we'll consider here. Similarly, TBC by angle opposite to TBC is 143.13. Sine 143.13 degree. Okay, and now the third force, the weight that is acting downwards, 5 into 9.81 by sine, the angle opposite to it is 96.87 degree. Okay, so we have applied Lamy's theorem at point B. Now we can find TBC. TBC is equal to 5 into 9.81 by sine 96.87 degree into, we'll take this angle, sine 143.13 degree. Calculate this value to get TBC, that is equal to 29.64 Newton. Okay, so we have found TBC. Now we'll consider the second point, C. This is point C. Similarly, we'll identify the forces acting at point C, and also we have to calculate the angles. So first here I'll calculate the angles. Already 70 degrees given. You just try to complete this triangle. This is 90 degree, 30 degree. So we can find this angle, that is 60 degree, right? Now also we can calculate this angle because this is already 90 degree. Weight is acting vertically downwards. So with the horizontal, the angle of weight will be 90 degree. Now calculate this angle. 360 degree minus 70 degree plus 60 degree plus 90 degree. What will we get? What is the angle? 140 degree. So this is 140 degree. So we'll draw the forces acting at point C. So here we are considering the point C. There are three forces acting at the point C. Okay, acting at the point C. The weight Q is acting downwards. So mass M is given. To convert it to weight, we multiply into 9.81 Newton. Okay. Now we have TCD, that is the tension acting in the chord CD. We have BC, which is the tension acting in the chord BC. This is TCD and this is TBC. TBC is the tension acting in the chord BC. Okay. So now we have identified the forces. We have to calculate the angles, which we have already done. And this is 140 degree, 60 degree, 140, 60 degree, and this angle is 160 degree. 160 degree. So we have the forces and we have the angles. Now apply Lamy's theorem. Apply Lamy's theorem. Just like we applied Lamy's theorem at point B, similarly we are applying Lamy's theorem at the second point C. So here applying Lamy's theorem, TCD by the angle opposite to TCD 60 degree, right? So TCD by sine 60 degree is equal to TBC by sine, the angle opposite to BC is 160 degree, is equal to the final third force mass into 9.81 by sine 140 degree. So here we already know TBC. We'll take this equation. Okay. In this equation, we already know TBC, right? Now we can find mass M. So TBC by sine 160 degree is equal to M into 9.81 by sine 140 degree. Substitute the value for TBC, that is 29.64 by sine 160 degree is equal to M into 9.81 by sine 140 degree. Calculate the value for mass. M is equal to, we can calculate it and we'll get 5.68 kilogram. This is the mass of block Q. Okay. This is a solution.